Go ahead and pause the video and try the warm-up where I want you to draw a segment and mark the congruent parts or the right angles in each figure. So these were the pictures. Remember, an angle bisector means that we're dividing an angle into two equal pieces because it's talking about angle B. Well, then I want to draw it through B where we have angle B being broken up into two equal pieces. Perpendicular bisector of the segment EF. So remember, perpendicular means we're forming right angles. Bisector of the segment EF. I'm bisecting a segment. That means I'm dividing it into two. Remember, perpendicular bisectors do not have to go through a vertex. So that's why that perpendicular line is not going through the vertex of D. A median from R means that it starts at angle R and goes to the midpoint on the opposite side. If it's going to a midpoint, it's dividing the segment into two congruent segments. An altitude means that we are forming right angles. If it's an altitude on the segment JL, well, it has to start from a vertex. That means this angle opposite that segment was angle K, so that's why it started at K, dropped it down so it could form a nice T-looking shape with that segment of JL, and I marked my right angles. So that's what we're going to continue working on today, looking at section 3.4, which is all about those special segments. So we're going to use properties of special segments to solve problems. We'll use them in proofs, and we will still use this idea of the auxiliary lines. So let's go ahead and take a look at an algebra problem. We are told that the segment MR is an altitude to the segment NP. So I would sketch the picture and I would mark it up. Just like we reviewed from that warm-up, an altitude starts at a vertex and is perpendicular to the opposite side. So perpendicular means that down here at R, we're going to have two right angles. We are told that the segment NR is 3x minus 11. We're told that segment PR is 1/3 x plus 31. We're told that the angle MRP, which is this angle right here, is 6x. So if I want to figure out if I have also a median, well, remember, a median is going to divide a segment into two equal pieces. But since I cannot assume that those two segments are congruent, we have to start with the idea that I have an angle being represented as 6x, but that angle we know is a right angle. So a right angle is 90 degrees. I get to set 6x equal to 90. So I'm going to divide both sides by 6, and I get a value of x to be 15. So in order for us to determine if we have a median, I need the segment of NR and the segment PR to end up being the same length. So I'm going to substitute 15 into both of those. So we'll do 3 times 15, then we'll subtract 11. Over here, we'll take 1/3 of 15, and then we'll add 31. So if we do 3 times 15, we're going to get 45. When I subtract 11, we get a length of 34. When I take 1/3 of 15, I am going to get 5. When I add 31 onto it, I'm going to get 36. Because these two lengths are not the same, my answer is no, segment MR is not a median. But remember, I could not just set those two segments equal because I did not know that they were congruent. If you did set them equal, well then yes, you're going to get a median because you already assumed it. So make sure that you're looking at the given information very carefully. All right, let's go ahead and take a look at a proof. So let's sketch the picture because we want to mark up the picture. We are told that our first given segment DB is an altitude. So once again, if we're given an altitude, that's a vocab word that we're going to expand on. An altitude starts at a vertex and is perpendicular to the opposite side. So D is the vertex that it's starting at. B is where it's going to be perpendicular. If we remember, perpendicular forms right angles. So that means that we have several right angles at B. So that would be the angle of DBA and the angle of DBC. So angle DBA and angle DBC are right angles. Once again, this is because if a segment is an altitude, because remember, that's what's given to us, then it forms right angles. That is what we are proving. So I can mark that I have some right angles. So because I have two right angles, I can continue to expand off this concept. Not only do I have two right angles, but now I get to say that those two right angles are congruent to each other. Remember, the reason for that is if two angles are right angles, then they are congruent. Okay, so anytime you're given an altitude, just like anytime you were given that symbol perpendicular, we have not one, but we have two extra steps that we get to state after the fact. That's all I could do to expand on that first given. I'm going to move on then to the next given, that angle A is congruent to angle C. And I'm going to mark it in my picture. All right, we can't expand on that any further. I don't have any more givens. Notice that what I'm trying to prove is that I have two segments congruent. Well, in order to prove segments congruent, which those segments are a part of some triangles, we're going to first want to get the triangles congruent. Right now, I see two triangles that only have two sets of markings. We need to get a third set of markings in order to prove that we have congruent triangles. And hopefully we're okay with the fact that if we're dealing with two angles that are marked, we can't get the third set of angles because angle, angle, angle is not a way of proving congruent triangles. So that means we're looking for a segment. The only segment that we can look at the picture and absolutely know, hey, we've got something congruent, is the segment that is shared between the two triangles. So that means that the segment DB is congruent to itself. That is because of our reflexive property. So notice that now I do have two triangles with three markings in them. We have congruent triangles. So triangle of ADB is congruent. Since I started with A, I have to start with then C. I want to go up to D and I want to end at B. So it's congruent to triangle CDB. If you look at the markings, that's because of angle, angle, side. So I want to look through my proof. I want the first spot where I have congruent angles in my triangle. Well, that looks like step number 3 when we had our congruent right triangle or right angles. Then I want another angle to be congruent. Well, that came from step number 4 when we listed the given. And then our congruent segments came from step number 5. And now that I have congruent triangles, any other pieces of those triangles are congruent. So we're able to go to what we're trying to prove, that the segment AB is congruent to the segment CB. And remember, it's the concept CPCTC, corresponding parts of congruent triangles are congruent. If I don't have congruent triangles, I cannot use CPCTC. Let's take a look at another proof. Once again, sketch the picture. We're going to be marking it up. Here we go. I'm going to write down my first given, that the segment of EH is congruent to the segment of EF. And I'm going to mark it in my picture. I can't expand on that any further, so I'm going to move on to the next given, that G is the midpoint of the segment HF. Midpoint is something that we can expand on. Remember, if a segment has a midpoint, we have two smaller congruent segments. Hopefully we notice that that would be the segment HG and the segment FG. So those two are congruent. Our reason is if a point is a midpoint, Then it divides the segment into two congruent segments. And I marked it in my picture. I've run out of givens. Notice that I want to conclude that the angle of EHG, which is this angle right here, is congruent to the angle of EFG right here. Well, I can't prove that those are congruent until I have proven congruent triangles. Here's the thing, there's only one triangle in this picture, but we can very easily draw in a segment and create two triangles that we can then try to prove congruent. Notice that I can draw in the segment EG. So if I go from E to G, I've now created two triangles. The reason why I knew I could draw that is because 2 points determine a line. It's one of our new postulates that we talked about. 2 points determine a line. Now that I've created these two triangles, I have two things that are marked in the triangles. I need one more thing in order to prove that the triangles are congruent. Well, notice that the segment that we drew is now shared between the two triangles. We can say that the segment EG is congruent to itself, and that's because of the reflexive property. Now I have two triangles with three markings that all fit nicely, so we can say that we have congruent triangles. So triangle of EHG is congruent to the triangle of EFG. And if you look at the markings, they're all from sides. So side, side, side. So notice that my first set of congruent sides came from step number 1. Step number 3 got me our next step. And then step number 5 got us our last set of congruent segments. Now that I have congruent triangles, we can prove that any other pieces of those triangles are congruent. So we can go to our conclusion that the angle EHG is congruent to the angle EFG, and that's because of CPCTC. So that is us using properties of special segments to solve problems, using special segments in proofs, as well as the auxiliary lines.